let's take a look. We are now going to start this section on trig functions and most likely finish it tomorrow. Because I'm going to guess we will be here but not have homecoming game, so we should have full class periods. That's my guess.
Yeah, we definitely not having home.
So,
That's pessimistic.
that's me. All right. So let's suppose we have an angle in standard position. So remember we talked about standard position is when your vertex is at the origin, the initial side is the positive x-axis, and your terminal side is anywhere else. So here could be an angle in standard position. And it has a point with coordinates x, y on the terminal side. So here's my point, order pair x, y. How far is it from that point to the origin? So if I wanted to find this, we could think of it as a triangle. This would be a right triangle. This horizontal distance would be what? What would this bottom part, what variable can I label that with?
Oh, that's X.
That's our x. The vertical distance is our, okay, let's call this side r for a minute. So then we know that in a right triangle, x squared plus y squared is equal to r squared. So if I wanted to find r, what would we have to do? Square root. So r is the square root of x squared plus y squared. We are going to be using that a lot today. And I wanted to show you where it came from instead of just trying to show you a formula. So the distance from a point on the terminal side of the angle to the origin can be found by doing this measurement. Oh, that's my theta.
Oh.
Just meaning the angle. Any other questions? So now let's define our 6 trig functions. So xy is any point except the origin on the terminal side of an angle in standard position. Then the definition of sine is y over r. So that sin, it is not sin. That is the shorthand for sine. So the first trig function, sine of angle theta, is y over r. COS, that represents cosine. And that is defined to be x divided by r. And remember, we found on the last slide that r is the square root of x squared plus y squared. Okay, tan, that stands for tangent of angle theta, is y over x. The other 3 are reciprocals. So this is cosecant, and it is the reciprocal of sine. So r divided by y. SEC is secant, that is the reciprocal of cosine. So r divided by x. And this is cotangent. And that is x over y. Okay, the key to being successful in trig is when I tell you you have to memorize something, you need to memorize it. These 6 definitions, we will never stop using them. So we will use this every day from here throughout the end of the semester. The sooner you learn them, the better your life will be. The people that say trig is hard are the people that fight me and don't learn the things I tell them they need to learn. So, these 6 ratios, it's just a definition. So we just have to know what the definition is. Now, I'm going to give you some shortcuts to help you memorize those. But ultimately, you need to know. When I say sine, that's y divided by r. Cosine x over r. Tangent y over x. So we need to know those. Make some flashcards if it helps you. Probably the easiest trick for memorizing purposes is SOHCAHTOA. Have you guys seen SOHCAHTOA before? So there's a reason that we define it with variables x, y, and r and not just SOHCAHTOA, because SOHCAHTOA really only works if we have a triangle. And we're going to see there are some situations where it is impossible to draw a triangle. So we can't only use that, but it is helpful, especially for remembering what those definitions mean. So if we think about a triangle. Okay, and that was from, the picture we already drew. If you have an angle in standard position, this is our angle. This was my horizontal measurement, which is x, my vertical measurement, which is y. This is r. But we could also label those using the words opposite, adjacent, and hypotenuse. So r is the hypotenuse. In a right triangle, the hypotenuse is always across from the right angle. From this angle, y is opposite because it's directly across. X is referred to as the adjacent side. Adjacent means touching. It's the side touching my angle. That's not my hypotenuse. So we have opposite, adjacent, and hypotenuse. So tells us that sine is opposite divided by hypotenuse. The S-O-H. If we think about my labels, the opposite side is my y. My hypotenuse is r, so it's the same ratio we wrote down in the last slide. It's just using opposite over hypotenuse as a shortcut. Ka means that cosine is adjacent divided by hypotenuse. Okay, if you think about your picture, the adjacent side is x, hypotenuse is the r. TOA means that tangent is the opposite over the adjacent. think about the picture, your opposite side is y, your adjacent is x. So same definition, just another way of remembering. Then the other three are just reciprocals. So the reciprocal of sine is cosecant, so we flip them. Reciprocal of cosine is secant, so we flip them. Reciprocal of tangent is cotangent. Are there questions from any of those? So I want to basically spend the rest of class today just using these ratios. One thing that I really want to stress, any problems that we're finding, I always want exact values. So I want it as a fraction in lowest terms. I don't want you to try to divide it and give me a decimal, especially because we're flipping these to get the other ones, and that's much easier to do with fractions and not decimals. So we are going to try to stick with those exact values. So here is our first example. The terminal side of an angle in standard position passes through the point 12,5. If you're writing this down, you don't want to write down everything, you can just write down the point is 12,5. We need to get the values of the 6 trig functions. We don't have to draw a picture on this, you are welcome to, if it helps you. You know, if you're plotting the point 12,5, that's just a point in the first quadrant. So this is the angle. Again, I didn't say that you had to sketch it, so you certainly wouldn't have to. What we have to do are the 6 trig functions. Now, you cannot just write sine equals. We will learn you always have to have an angle. Sine is like an operation. You know, I can't just say square root and you guys know what to do. You have to have the square root of 9 or the square root of 36. So I can't just say sine. I have to say the sine of what? So it's the sine of angle theta. Cosine of angle theta. Tangent of angle theta. And they're reciprocals. Right, so in an order pair, we know the first number is x and the second one is our y. So our x is 12, our y is 5. How would I find r? Square root of x squared plus y squared. If you don't want to feel like you're memorizing another formula, just think of the Pythagorean theorem. X squared plus y squared equals r squared. So r is the square root of 169 or 13. So now we're just going to do all of our ratios in lowest terms. So sine, what's the definition of sine? Y over r. So that would be 5 over 13. And if you know sine, we automatically know cosecant because it just flips. So cosecant is 13 over 5. Definition of cosine, x over r. So my x is 12 over 13. And that means secant, the reciprocal, would be 13 over 12. Tangent, y over x. So 5 over 12. And so then cotangent would be 12 over 5. If you like using the SOHCAHTOA definition, then the picture would probably help you, so you knew. The opposite side was 5, hypotenuse is 13, and you could label those sides. What questions, students?
What I'm not gonna remember is y over x, not x over y for tangent.
You'll get it. Repetition helps a lot. Let's look at this one. If I told you to draw it, what quadrant is this point in? Positive, negative. So we're looking. See, all good. So this is the actual angle we're looking at. And we know it could spin different ways. But if I ask for a picture, you could draw that. We need our x, y, and r to do our definition. So the x and y are given. So x would be, y is, and then r is the square root. So we get square root of 100, which is 10. All right, you guys do the 6 ratios from there. If you are one of those people that really like the SOHCAHTOA definition, and that helps you, you can certainly think of this as a triangle. When you do that, the angle always has to come out from the origin. So your angle is here. So this would be our opposite side, which would be a -6. The adjacent side would be 8, and your hypotenuse is 10, if you like using that picture. So the definition of sine, y over r, we're opposite over hypotenuse. So we get -6 over 10, which can reduce to -3 over 5. Then cosecant, all you do is flip it, so it would become -5 over 3. Cosine is x divided by r, so 8 over 10, which reduces to 4 over 5. That means secant is 5 over 4. And tangent is y divided by x, so -6 over 8, or -3/4. So cotangent is -4/3. So you do have to watch your negatives. Any questions on that? How much time? Let's look at one last problem for the day. So, we're doing the values of the 6 trig functions. But instead of giving you a point, I gave you an equation.
No, slope, right?
Are we gonna have to do the open dot and all that?
No, we're gonna. It'll be easier than that. So, it actually, if you have an angle, it does not matter which point you pick to set up your ratio. So if I think like back to this one, I had this big triangle, and you could think of your ratios from there. But if you pick this triangle, aren't those similar triangles? They're proportional, and we learned, I want to say last week, but Monday, that those sides reduce to the same, okay, if they're proportional. So all we have to do is find one point on this side, and then we can get our x, y, and r and work our problem. And actually, everybody in here could come up with a different point, because we know any line, there's an infinite number of points on it. So we have to plug in a number for x. But what do I know about x? It can't be.
It's less, it can't be greater than 0.
Okay, so we need a negative number for x.
Negative
Alright, so if my x is negative 1, then I have to use this equation to find my y. So I could add over my 3. Oh, what's wrong? It's a fraction. Do you guys want to do the fraction?
Yeah.
We can, but we don't have to.
Alright, let's bump it up to -2.
Okay, why is -2 a good option?
Because you'll add the next half.
Yeah. Here's an easy way. If I started with these points, they're proportional. That means you can multiply them both by the same number. So if you multiply by 2, you would get a -2 and a -3. And then are those better to work with? Yeah. So if you get a fraction, as long as you multiply them both by the same thing, you get your integer values that are easy to work with. And you can confirm, if I put in those points, it does in fact equal 0. So I have my x and y. Now we need r. So r is the square root of x squared plus y squared. So we get the square root of 13. Okay, with radicals, I do not want a decimal, but I want you to reduce your radicals if you can. Can we write down the square root of 13? No, so we're just going to leave it. Alright, so now we have x, y, and r. So sine.
But we can't have square root.
So sine is y over r. So that's -3 over the square root of 13. What's wrong with that? Okay, how do we get a radical off the bottom?
Multiply by the radical. Whether it's a radical.
You're so dramatic. So we get -3 radical 13 over 13. Okay, so for cosecant, we know that's r over y, right?
It's just square root of 13 over -3.
Mm-hmm.
You're gonna make Megan cry.
It's fine.
So cosine is x over r. So -2 over radical 13. But we have to move the radical. So secant is the reciprocal. Or if you're thinking of it as just flipping, always go back and flip the one before you move the radical. Make your life way easier. So you don't have to move it again.
This one's easy.
So tangent y over x, so -3 over -2, which is a positive 3/2. That means cotangent, if you flip it, is a positive 2/3. All right. Questions? We'll get there.
You can't have a radical on the bottom. Oh, it's, okay. Right. Now I understand.
We are not done with this section.
Homework.
So, I will add to this tomorrow, and then it would all be due on Tuesday. So tomorrow we will finish and add to the assignment. So get started. If you get all this done, great. If not, you will have a little more time tomorrow to work.